Okay, in this next video, let's take a look at the idea of a composite function. I'm not going to go into a great deal of depth on this. The whole point is simply to kind of refresh your memory of some stuff from algebra that you really need to have. So, see, given two functions, and I'm going to call those functions f and g. The composite function which denoted f, we put a little circle here, g, and that's red, f composed of g, is defined by, we'll say f composed of g of x is actually equal to f of g of x. So this function f is actually made up of g of x. Now, 99.99% of the time when I'm working with composite functions, this is a notation that I use. Actually, the only time I use this notation is when I'm introducing composite functions, because the book uses this quite often. A lot of textbooks use this, but you won't see me use this hardly at all. This is what I'm going to be doing as a composite function. So let's just say that we need to evaluate this for x equals 2. Well, what this means is, number one, I need to find g of 2. That's some number. Let's just call it k. Let's just say k is some real number. Okay, now we need k. This must be in the domain of f. If it's not in the domain of f, then I have something that's undefined. So now what I'm going to do is simply find f of k, which is equivalent to f of g of 2, because g of 2 is nothing more than k. So let's go ahead and do a couple of real quick examples here. Let's let f of x equal x squared minus x plus 1. And g of x, well, let's do g of t, because it really doesn't matter, is 2t plus 1. Now what I'm going to have is f composed of g of t. So f of g of t is going to be equal to, now remember, everywhere there was an x, I need to put g of t in. That's what function notation is all about. So rather than x squared, I'm going to have 2t plus 1 squared, because g of t is my new x, minus x, but my new x is 2t plus 1, plus 1. So now f is actually a function of g of t and is actually a function of t. So for, let's say, t equals 2, we would actually have, let's find g of 2. That is 2 times 2 plus 1, that is 5. So f of g of 2 is actually equal to f of 5, which is equal to 5 squared minus 5 plus 1. Now, notice if I just put 5 in right here, because g of 2 is 5 and this is g of t, well, if I put that in, 2 times 2 is 4 plus 1 is 5. That's the same 5. 2 times 2 plus 1, that's the same 5. That is g of 2.